Today's lesson, we're working on volume. It's H&I, same skill, same technique. First part in any of these measurement chapters, you got area, you got length, and then you got volume. So it's just three things to work with. You have to know conversions. Now the conversions that you're familiar with are these ones. So the length conversions, you know how to do millimeters to centimeters to meters to kilometers. Like this. And then, that was year 7 in primary school. Okay? Then in year 8, I then re-emphasize how do you convert area units. And the only difference with area units, where they have these squares, it also means when you're moving between them, remember from centimeters to meters, we are then dividing by 100. But remember, if it's an area unit, then it must be 100 squared. Okay? That means all of these would be squared if they're area units. But if you're now working in 3D, which is volume, volume is cubed. Why is it cubed? It's because you got 3 dimensions. So each one you have to convert. You convert it 3 times. That's why it's cubed. Okay? If it's cubed, the only difference is this now. If it's a cubed unit, millimeters to centimeters to meters to kilometers, everything stays the same. Except you're cubing. So copy this one down. If you're likely to forget these ones. Oops, sorry, that should be 100. So copy that down if you have volume units. And how do you know it's volume? It should have a cube on it. If you have those cubes, then just make sure that when you're moving between centimeters to meters or kilometers, they're all being cubed. Okay, that's one of the ones that most students miss, and that's why their answers are wrong. So just type it on a calculator, but it's just the fact that they forget to do it 3 times. So this just means divide 10, divide 10, divide 10, divide 100, divide 100, divide 100. Yeah, that's for cubic. Anything to do with volume. So I'm going to write here area. This is called area units. This is called volume units. So exactly the same. The only difference is it's cubed, squared, and length units you don't need a square or cube. Now volume, when you're talking about 3D shapes, there are actually a few more that we can also use on what we measure. We don't always measure everything in what we call length units. Okay, so in your notes here, notice that I got a little space down here that says volume, then measure in something units. Fill in, say length units. When you go buy something like, for example, 2 years ago, there's a playground in the house that I bought in Viewbank. There's a playground there, and around it was just muddy. So I decided to buy bark to put on so that when you walk on it, it doesn't stick to your shoes on wet days. So I needed to fill up the space. This is what the playground kind of looks like. It's got this kind of space, and the playground sits in that space there. Yeah? So I should probably draw it more correctly. It's actually sitting right there. And the slide actually goes this way. So this bit here, I needed to cover with bark. So to work out that, I just worked out the area, kind of what you guys did. So I worked out the 2D space that I need. Then I worked out, well, how deep do I want it? Okay, so do I want it this deep? Do I want it this deep? So I just got it to the depth of one of those wood planks that you see, those barriers. It's just wood plank is about this big. And I just timed them all together to work out the volume. But when you go buy bark, they only measure it in terms of, and it's measured in this length units. When you go onto a website, say Bunnings or something like that, when you buy them, they usually measure in cubic meters. Okay, so when you have the options, you can choose 1, 2, 3, 4. 1 cubic meter, just for you guys to visualize that. That means It's 1 meter by 1 meter by 1 meter. So you think of it as a box. That's 1 meter. So what does that look like visually? It's like this. Me taking one step, that's 1 meter. Me taking another step, that's roughly the space that it occupies. And imagine I can step up in the air, that's about 1 cubic meter. Okay? So that 1 cubic meter is what you feel with bar. That's how much you buy. It's about how much? It's usually about 50 to 60 bucks per cubic meter. So I worked out the maths. You know what's interesting? I got the volume of that playground. It was nice that it was nice and rectangular. I just split up into two rectangles there. I worked out the depth that I want, got the volume. But you see, when you measure, when you open up your tape, when you do a measuring tape, what are the units or the measurements on the tape? Mils or centimeters. Yeah, when you pull it out, it's mils or centimeters. So that means even when I got the area, whatever the area was, it would have been in cubic centimeters. Sorry, areas, squared centimeters, and I times it by the depth, and I have a volume, but it's in cubic centimeters. So when you go buy stuff, it's not in cubic centimeters because the numbers would be too big. They're 1, 2, 3 cubic meters. So I had to use just a simple maths to convert my volume of the playground into cubic meters. And it worked out that it was exactly 3. So then I went online, I just went, all right, cool, click 3. It was about 100 and something, couple of bucks. Paid for it. And what was interesting that when I filled it, wheelbarrowed, I did it like 20 times, just going up and down the hill. And I filled up that playground. You know what, it was cool? Because it was perfectly rectangular. And obviously this depends on what you buy as well. But bar happens to sit exactly, you know that plane, it actually sat exactly in the height all the way through. All the way through. And I was like, only my students could see this because we're doing literal year 7, 8 mathematics. I worked out how much I actually needed to buy. I didn't buy overbuy and I didn't buy under. And it just fit exactly what I wanted. Had I bought a bit over, then I'd probably put it at the front yard. But it was exactly just where the playground needed. And I'm like, yeah, kids can just think for themselves to do that. But that's what 1 cubic meter is roughly. So if you ever need to learn, that's the use for the conversions. Yeah? Problem is, not everything that you buy is in cubic meters. You see, if you go, say if you were buying a swimming pool, they don't measure in cubic meters, they measure in liters. Buy a tub, they'll say, oh, that holds, 30 liters. How do you convert, how much space is that? So volume can be seen in 2 ways. Volume is measured in length units. So you can have cubic meters like the one example I just said. But it could also be, when they say capacity, they mean liquid. So fill this in. Liquid or gas. How much it can contain. Same idea, but it's just different measurement. So one is measured in liters. One is measured in length units. Yeah? So one's in liquid form, and then one is in actual form, like length form. Yeah? So, now you need to learn this one. So this one, write it in if you weren't familiar, but most of you should know how many meals make 1 liter? 1,000, very good. So when you buy one of those like milk cartons, 1 liter, there's 1,000 meals in there. So to convert from liters to meals, it's times 1,000. And this is now divide 1,000, so fill that in. Anyone know what KL stands for? Kiloliters. Now it's very similar to meters to kilometers. How many liters do you think fit into a kiloliter? 1,000 as well. That's what kilo is, yeah? So this means 1,000 liters makes 1 kiloliter. What's the capital M? Mega. Very good. Megaliters. So this represents mega. Okay, megaliters. This is milliliters. So little m is milliliters. And again, 1,000 of these kiloliters will make 1 megaliter.
Oh, so it's always 1,000.
Yes, that's why it's easy for liquid form. So anything that's liquid, most of the time you're probably working within these two. Okay? So it's divide 1,000. Divide 1,000. Here's some useful conversions that you might more likely use in your own time. So 1 meal is equivalent to 1 cubic centimeters. To give you a visual aid so that you understand what that is, because we just write things down but we don't actually visualize what it is. 1 mil, when you say 1 cubic centimeter, it means 1 centimeter by 1 centimeter by 1 centimeter. This little cube is one of those little blocks that you played in primary school. You know when you first learned ones, tens, hundreds, and you had those wooden blocks? One of those units, that's a 1 by 1 by 1, that's 1 centimeter. What that means is if you were able to make it hollow and then you poured water in it, that little block that you can think of, that holds exactly 1 mil. That's how we measure it. Okay, so one of those blocks is 1 mil. That's what it represents. So, one other extra special thing, and this is only an approximation, okay? But it's good for you to visualize how things work. 1 mil is approximately 1 gram. But it's 1 gram of water weight, okay? Because everything is different, like water is different to oil. They have a different mass to it. So approximately 1 mil is about 1 gram. Now, why is that useful? I did this just last year when my daughter was born. She's got eczema, and one of the recommendations from the hospital is that I need to do bleach baths, especially when she starts having infections, when she scratches too much and it bleeds. So to do these bleach baths, they recommend for every 10 liters, it's approximately 12 mils of the bleach. Okay? Sounds easy. 10 liters of water, pour in 12 mils of bleach, right? Here's the problem that we encountered. When you buy one of those baby tubs, they're usually angled so that they can sit nicely up, okay? Because they can't sit up. Because it's angled, when you pour water in there, it's not like they have little measurements to tell you when you reach here, it's 1 liter. When you reach here, it's 2 liters. You actually don't know how much it truly holds when you pour it in. So how do you measure that you've actually got exactly 10 liters so that you can then squeeze in 12 mils of bleach? So the problem is, if you pour water in it, you can put it under a tap, you can take a bucket and pour it in, but you won't know how much exactly. Every time you do it, it's going to be slightly different. So how do you ensure that's exactly the same every time you do it? I wouldn't want my wife to do that because I'm at work and then she's trying to figure out how to get 10 liters into that bucket. So I told her, well, I know this approximation. Let me calculate this for you. 1 gram is roughly 1 mil. Now, if you want 10 liters, you know that there's 1,000 mils for 1 liter. But 1,000 mils is equal to how many grams? 1,000. But 1,000 grams is roughly how much? 1 kilo. So with that fact in mind, I told my wife, I said, make it easy. Take that tub. The nice thing is the tub actually has a weighing scale on it. But for anyone else, you can just take the tub, put on a weight scale, and then you can use the biggest bucket of water you want, fill it up, and pour it in, or just put it under the sink. And you just need to fill it up until, and you don't need to know how much mils, you just look at the weight. If it's roughly 10, if it hits 10 kilos, she knows every time that she does it, it's going to be exactly the same. She just makes sure it says 10 kilos, 10.00, that's roughly 10,000 mils. 10,000 mils was roughly 10 liters. And that saves her time because the only other way she was going to do, you know those cooking mugs? That's 1 liter. They have 1 liter cooking mugs that you can do. She was going to go fill that up to the brim until it gets 1 liter. And it goes 1, 2, 3, and do that 10 times. Now you can do that. That's probably what most adults would have done if they were trying to do that. But with just a bit of maths knowledge, I was able to do that quicker for her. So just giving her an instruction, say, turn on the scale, fill it up until it's 10 kilos, and you should be good. And then just do that. Yeah. So now her eczema is like much more controlled. With the bleach baths, we only do that when there's infections, but that was one way. So copy that down. That's a useful conversion that you might want one day for yourself. Every gram is roughly 1 mil in terms of water weight, and 1 mil is roughly 1 cubic centimeter, which is one of those little ones that you used to play with in primary school. Okay, that's a visual aspect to it. All right, so we know 1 liter is 1,000 mils. That's a useful one that you would likely do. And then this one, this is just good for you if you ever bought a swimming pool and you want to visualize what it looks like. they're usually measured in terms of volume of water. 1 cubic meter, I told you before, was like one of those moving boxes. 1 step across, 1 step up, and 1 step in the air. That 1 cubic meter is equivalent to 1,000 liters, which is 1 kiloliter. Yeah, so one of those boxes, if you had to fill it in, you know it can roughly hold 1,000 liters of liquid. Obviously, liquids can change depending on what you pour in, but in general, if you just think about one box, the moving boxes, you can fill in 1,000 of those liters. Meaning, if you got 1,000 of those milk cartons that says 1 liter, one of those boxes can hold about 1,000 of that. You can pour about 1,000 in. Okay, so that's a way to visualize what these numbers mean. Okay, so these are the common conversions that I think students likely use, especially in foundation maths. This will be useful for them when they're doing conversions. But that's it. So that's the first bit of 4H that I want you to understand. So you got 2 types of volumes, length units, liquid units. Yeah, both of which I used. One was for buying, one which was a bleach bath that I was doing. And surely there's a lot of other things you can do. Especially if you get into a trade course or something, these conversions are very useful. Yeah? All right, here we go. Let's move on. So, what's the second thing I want you to learn today? Very simple formula. Fill in this one. Volume. The formula to find the volume or the space of any 3D object, or not any 3D object, but specifically the one we're doing today, is area times height. This area is not just any area. Can you write underneath? It's actually the cross-sectional area. And I'm going to be very specific why I said cross-sectional and why it applies to what we're doing today and then also tomorrow's, the next exercise session as well. Okay, so why is it area by height? See, I want you to understand this logic. The reason why it's area by height is because it starts off with 1 dimension. That's a length. Then we say, all right, well, what if I took that line and I repeated itself? So I stacked it next to each other all the way down. If I stacked it like this, if I just stacked them infinitely close to each other, you see, the more I stack, I create space. So then that means there's a second dimension here. Can you see how you get that second dimension? So the more I stack, that's your second dimension. That's why the area is length times your second dimension. Because that's how many of them you need. So one length, how many of these lengths do you need? You need the number over here. So that tells you the area. But once it tells you the area, that's only 2D. That's space. That's flat. If you now want to make it 3D, you need a third dimension. So a third dimension could be that I could extend it forward. And if I extend it forward, can you see how this now gives you that 3D shape? See, if I extend it forward, how many of these sheets, 2D sheets, can I fit along this line? See, if I fit it infinitely this way, I then get the volume, the space. So this is the area that I'm talking about. When we say cross-sectional area, why is this important to understand? You see, back in primary school, when I ask students, year 7, I say, what's the volume formula? Most students think of this. Length times width times height. They memorize that. Length times width times height. Yeah? This is only specifically for anything that's a rectangular prism. And why does this work? Because when we say this area, so length times width, you get this 2D area. When we say cross-sectional, you know what that means? It means that no matter where you cut, boys and girls, thank you. And I'm teaching. I don't know what you're doing. I'm teaching, I don't know what you're doing. But I'm teaching. I'm teaching. You wash your hands afterwards because this wouldn't have occurred if you were just doing what I'm doing. Copy my notes. Otherwise, sit there quietly. Sit there quietly or copy my notes. But I'm teaching. Because what you're doing is interrupting my teaching, and that annoys me. So again, you chose to be in my class. Don't do that. Don't be that. Here we go. So we've got cross-sectional area. What is cross-sectional area? It means if you were to cut this block and you split it up, right? If you split it up, if you cut it down this way and you split that shape up, what you will get is you will get two pieces that looks like this. But the key part is this front face. That area is the same area as that one. That's what we mean by cross-sectional. Cross-sectional means that when you cut it, no matter where you cut, the shape of the area is exactly the same. Okay, all the way through, because it's consistent. This is kind of like your, let's think of another shape. Like one of those Toblerones. See this one? Same thing again. Here's your flat 2D area. It's a triangle. There's a 3D length, but no matter where I cut, if I cut it this way and I split the two up, you will still get a triangle of exactly the same size. Then the area or the volume is this area times how many units do I need of them? How many of those areas, same areas all the way through? That's why it's area times the third dimension. Does that make sense? So this is 2D, third dimension. That's how you make it 3D. That's why the formula is area times height. That's why in all these formulas here, notice length times width was just the area of a rectangle face and times it by the third dimension. That's why even if I gave you a cylinder, which is the next exercise, this is 4H, if you did 4I, see a cylinder has the same property. See a cylinder, no matter where you cut, same thing again. If I cut down this way, the face here is a circle, and if I separated this, this is still a circle when you split it out. The same area. So we just need to know the area of this 2D area, and then times it by the third dimension to make it 3D. That's why it's area times height. But out of these shapes that I drew, they all have something in common, right? That means they all have to have a cross-sectional area. What shape that you learned back in primary school that's 3D that doesn't have a cross-sectional area? Yeah. See, a pyramid, even if I drew a square-based pyramid, the square on the bottom is not the same square even if I cut it this way. That gets smaller. Each one, as you get closer and closer to the top, the area is different. This is a different cross-sectional area. That's why we can't use the same formula that you have here. Well, this one, pyramids have a special own formula. Same thing with spheres. So at year 8 level, you're only learning shapes that all have a cross-sectional area. So here, I'm going to show you. If you have a look at all the shapes, your first skill is you need to identify when does the rule work. See this one? Front, back is the same. No matter where you cut, the area is the same. If you have a look at this shape, it looks funny, but same idea. Top area, that weird looking shape, on the bottom is exactly the same. The top and the bottom is exactly the same. So all you needed was the area of the 2D times by the third dimension. And that will give you a volume. So this question here, that looks crazy, is just 11 times 4. Because they already told you what the area is. Okay, so if you have a look at all the shapes here, every one of the exercise questions, they are cross-sectional areas. That one, same thing, the front and the back, same area, cross-sectional, cross-sectional, cross-sectional. None of it is a pyramid. And so when you're looking for the formula, you're trying to solve for the volume, the first thing you should be looking for is, where's the 2D area that is the same throughout? Once you know the area, times by the third dimension, and that will give you a volume. Make sense? That's it for, that's H and I. So I only taught you two things today. Unit conversions, how useful they can be from liquid to length units. Second one, how to find volume. So the two exercises, they just do a bunch of different shapes, but it's the same idea. Find the area of the 2D, then times by length. That's why you need to know B, C, D, E, F. You got to learn all 8 rules so you can find the area of a 2D shape to do volumes. Okay? So remember, tomorrow's session, it is your time. That's what I want you to work on to catch up. All right, I'm going to pause the video.